Here we start a little bit more speaking about software management and the way we are doing the things in sciCore. Here, just a few things. What has changed over the year about the users, especially the scientific users. Then what has changed for the administrator. And then we will have a look at the sciCore, how we implement the software management, what was our goal, that's an overview of our architecture that we had at sciCore, how we implemented the whole stuff. Then we will have a look at the virtual infrastructure, because we have virtualized a lot of stuff that we are using. Then the workflow, how we install one node, one server, one service, whatever. And I will give a short word about Ansible, because it's one of the components which is very important in the whole stuff that we are using. First, in the software management, we have see that the requirement from a user has changed over the year. The first time when I started HPC, the people need a compiler, some libraries or some parallel libraries, and they were happy. Maybe you put it one or two applications for the chemistry or for the physics, and you never heard again about the people. They were linking, making their own software, everything, and they were happy. Things have changed now, because we see more and more people use a lot of software on different stack, and the whole stuff is getting more and more complex. You need this library, this software, this kind of piece, and the whole thing is merged together with all the problematic, with the revision, the version, and so on. I will also more and more need some tools for visualization, for statistics, and so on. And the combination of free, third-party black box application makes the whole stuff very complicated to install and to manage. And for more complicated, we have a lot of different versions, and the things are not fitting together between the different versions. So you need a new version for that, an older version for that. Sometimes there is a bug on the new version, this work is not going. You need to have an old version for this reason, and so on. And there is another thing also changed over the year. For some years, the people came with their own application. Now they say, I need this application. They are coming, say, for my research, I need that. And they are expecting that you install it. They will not install it. They say, we have no time, we have not the knowledge, and so on. They also come with requirements. We need 2, 3, 4, depending on the sum. Sometimes you have up to 4 versions from the same software for different needs. And there is also something, software is sometimes working well with Intel compiler, but for another part, it's not working well, it's working better with a GCC. Or some parts are not be able to link with Intel when you need another one. So we have also applications that we link with different tool chain. Intel, then GCC, we have also Portland, and yeah, depending on the needs. And some software are only working with the first one, some with the second one. It's sometimes a nightmare. So we should also be able to use different tool chains. And that has really changed in the last 5 years. The requirement and the expectation of the user are bigger and huger than before. This has, of course, a big impact of our job, because we have now to face these new challenges that we were not. So what's new? We now have a large amount of software that we have to maintain, what was not necessarily the case before. We have a software is also, the complexity is also bigger, and the integration between the different tools is not necessarily it's not perfect. We have, it's developed in this university, they have this kind of software and these kind of tools, when another part is developed there, and you at the end have to merge both things together. And we have also to deploy the software stack on different environments. We see that we need it on compute node, but sometimes we need it on some special application server. Say, oh, for this part I need this kind of software on my server. We can need it on virtual server, We will show you, we have a case where we just deployed the whole stuff on the virtual server. So we must be able to develop the software stack not only on the compute node, but on a lot of different platforms. And for that, of course, we will not do that by hand. We will looking for if there is a way to automate the installation, the upgrading, the configuration, and even removing all this software. And we are looking for tools, or we are looking at this time for a tool who was supporting the normal packaging format, like RPM and all these things that you know better than me, but also our installation method, because not everything is standardized. And when we decided to change, because we had to merge two environments, so it was really a good time and a good opportunity to change our part how we managed our software. And the first thing that we decide is not to make two trees for each cluster, but we decide to standardize and to centralize the whole stuff. And one of our goals was to be able to install and deploy the OS, of course, because we have many nodes. But we also wanted to develop the development tool and all the library, and the different software tools and the different application. So we wanted to deploy the whole thing in a central management. And we decide for a shared environment for one reason. It's to optimize the resources. You make it only once. We wanted to reduce the deployment time and the costs. We don't have, sorry. We don't want to do it twice, only once. It gives us a higher flexibility. It's on one central place, and we can push it everywhere. You will see it. It was also to increase the scalability and the efficiency. And here, what's our situation? As we told, we have still two clusters. They are completely located. This one is located in at least 3 rooms. This room is located at 2.5 rooms, and we have also the storage. So what we made, we start, as Conchi told you, we had start to make the storage on one virtual environment, so it is accessible from BC2 and from Maya. The reason why we put all this cable between the rooms. So now we have a situation where we have a centralized storage, one cluster who can access everything, and the second one. But at sciCore, we have not only nodes, we have also some application server, and we have some web services that we also deploy. And what we made, we put just in the middle of our management layer. And this management layer, we push the software on the different part where it is needed. So just a short view what we have. The implementation, we have a centralized architecture, and we put the whole stuff on a virtualized environment. The tools that we used, you will see, they are mainly open source based, and we provide the installation and the provisioning for the OS, for monitoring and reporting. We have a resource management in this environment, the software installation deployment, the application installation deployment, and the user management. Now, a very short view on the virtual infrastructure that we use for the software deployment. It's based on Xen. We have 2 servers, and we have 1 file with 2 heads, and then we have our different volume that we have here. So everything is completely redundant here. So if this one breaks, this overtake. If this one breaks, it's overtaken here. And we can also scale, because we can put 2, 3, 4 servers if needed, and we can also extend our file here or the space, whatever. These are just a short view from the product that we have. And as I told you, with this environment, we populate the compute node, the logging nodes, web service, application server. And here, partially, it's not, we also are starting to populate the file service, the software storage. The last server that we installed was installed completely from here and pushed everything except the data. And now, just a short view of our workflow, how it's working, when we are getting new hardware or whatever, what are we doing to install the whole stuff. We have here two things that you see. If it's hardware, we are in this part. So we get a physical first server. And then first thing that you do, we deploy the OS. And that we do it with the product is called Foreman, where we just make the minimum configuration to have an access for the overflows. So we put just the minimum from the Linux system, and we put the keys who are needed later from this part to configure the software. So when the server comes, it's configured in Foreman. We boot it, install it, and once the OS is here, then we start with Ansible and automating the configuration. So we prepare the nodes with one script of one play, where we put the whole automated configuration, and if needed, if there are special application, in the same stream we also put all the application on it. And at the end, we have a physical server who has everything who is needed, all the software is needed, and all these things at the end to monitor, to manage the server, to deploy the queues on it, or the jobs on it, and everything. So we have a part here for the reporting, and here we have a part where we deploy the configuration, the application, the patch if needed. We can also upgrade here, where you can modify the configuration on one central places. If, for any reason, it's a very short thing, we decide you can also start a virtual server. And then the process is more or less the same, except the first step, where we just deploy a new image that we use with a copy from the Xen, from a base image. And the rest of the configuration is again made with Ansible and all this stuff. And at the end, we have exactly the same thing here. So the whole things what we deploy now is defined here, and that's just for the OS. That's a very short thing. Yeah. We have also here the Git. That means that all the configuration, everything, we put it immediately on Git for the documentation. So we have also the different version. We can roll back, go forward. And then there is another very important part, because that's EasyBuild. With EasyBuild, we deploy the software that you usually see. All this stuff that you generally make install, and all these things. And all this software, we do it with EasyBuild. I will not go further on that, because Pablo has a presentation only on this part. And he will explain you why we decided to use EasyBuild and the main advantage from this tool. Here it's just Ansible, because it's the other important part from the deployment. And why we chose Ansible in a few ways. It's a non-client server architecture. You're on this place, you only use SSH. So you have not to deploy any daemon, nothing. You just need an SSH key on your server that you want to manage. And the rest, you deploy the whole thing without any need to install whatever on the other side. One access, and even if you have not the key, you can use a password that you give in. Now, at this time, there are over 200 modules that are available to deploy the configuration, to make scripts or whatever. And the extension, if you need any more, it's in Python. So everybody knows today is confident with this kind of software. Then Ansible has with the so-called playbook. It's a configuration, deployment, and orchestration language. It's written in Elm, and you have step by step what you need, and you give exactly what you want to do with the server, and in a sequential way. So if you need first to install the database, you install the database. When the installation of the database is fully completed and available, then you can start your installation of the web server, and so on and so on. And not only on one server, but on different servers. So if you have one server here with the database, and then this software needs to have an access to the database, you can first install your database on another server. You install your application. And in a way that this one is waiting up, this one is ready. So you have to prepare the playbook in this way. The never other good thing is the whole stuff is using the YALM configuration, and it's more or less self-documented. There are a few rules to follow, and when you have finished your playbook, you don't have to document it. It's already documented. And when you you know how it's working, you can read your book, even if you have not written the whole stuff, and you can understand it. There is another thing which is very interesting. It's supporting ECM, OpenStack, Docker. And with EC2, we made it because for 3 weeks, we had a network outage. They completely closed the university network for 3 days. But we have some web servers where very important, who have to be there. And because we had no network, we had no other way than put them somewhere else, and we put it in the cloud, EC2. And we use the same Ansible script to deploy the server by Amazon, but we use it to deploy it internally. So with very few things to change, we were able to deploy the whole stuff outside very easily. And we use, for the moment, Ansible to automating configuration. So we deploy the whole configuration, but we also install, configure, and deploy applications. That's the reason why we chose Ansible. If you have any question about that, before I give a hand to Pablo. Yeah.
Will you distribute the slides?
Pardon?
Will you distribute the slides after the conference?
He will, I think Michele will tell you where he distributes the stuff.
Put them on the website.
Yeah.
How much do you pay for this Ansible?
It's free.
The Ansible tower is like what?
Yeah. Ansible is free. It depends. You can have it with support and without support. We use the support.
This is only the support.
This is a web interface.
When you go on the Ansible side,
Yeah.
This is,
Yeah. Ansible, they have an option now where you have also a graphical interface, and you pay for the graphical interface. But for the normal Ansible, the tool to deploy the whole stuff, you don't pay. And it's very easy to use. The stuff is very easy to read, and you don't need this graphical interface. And the second is the graphical interface is ongoing. They are working on. It's more, it's not completely finished. But you can use it without that. So it's for free for the moment.
It's called Ansible Tower.
Yeah, the tower is the graphical interface, yeah. But Ansible as tool is free for the moment. Yeah?
A question about Linux flavors you are using. Can you apply?
We have CentOS.
Always CentOS.
Yeah.
So I run 7 now.
No. We are by 6. Oh, no. No, it's not. Yeah. We are not ready. We are running for the moment 6.5. And normally next week we should deploy our first stuff with 6.6. We have some web server. We are with 7. So 1 or 2, but well, isolated stuff. But the main cluster is running with 6.5 for the moment. Yeah.
How many nodes are you able to deploy at the same time?
We got, in January, we had to reinstall the whole Maya, about 300 nodes. We started at 2 o'clock, and then 6 or 7 it was finished. And we've started by scratch. So we reset it and reinstalled the OS from the base.
So the whole at the same time?
Yes. Yeah. Ansible has some rules, so it's not populating everything at the same time. He makes by bunch to not overload the whole stuff. But we reinstalled more or less 300 nodes in less than 4 hours. Except the software tree on Maya, which is an exception, we will disappear. This time took a little bit longer at the end because we had to push 150 gig on each node separately. But that's a thing that we are now changing because we have no access to the central storage in a better way. Then these will be moved there, and this part will fall completely away.
Do you have a separate management plan for provisioning stuff, or are you using the same lab capacity as all the users?
No, the whole thing was made over a normal Ethernet. So, there is one part which takes a certain time. It's the part when we push all the RPMs that we need, the standard RPMs. Because when we are starting, we have a very short image from the Linux. And Ansible populates then every RPMs that we really need. Yeah.
When you install everything from scratch, how do you handle the host keys?
The host keys are on the distribution that we push there.
When you deploy the Foreman, it's using kickstart.
Mm-hmm.
And in this kickstart file, we deploy the key.
Key.
We put the key in place.
Yeah. But Ansible, you can use it without the key. You can say, I want to run it and ask for a password.
No, but when you install 300 nodes automatically.
Yeah, but even if you have no password, you can, when you have finished, when you know that you have an OS, you can say, no, install this 300 node with a password. And then you give in one with the password, and you can also do it in this way.
The first step is kickstart installation, which is
Yeah.
the really minimal installation. Yeah.
And
then there's the key that the Ansible management machine can get on the machine.
Yeah.
It's two steps. First step, minimal installation, and then next step,
Is it unique or the same for all hosts?
same key for all hosts.
Same.
Yeah. For it's
It's coming to tomorrow.
yeah. It's when we here we distribute the key. At this time we distribute the key. But as I told you, even if you had not distributed the key, you'll be able to deploy everything with once the password. And you can give it over the command line, or you can whatever. It's possible even if you had not. And with Ansible, you are also able to distribute the key later, so if necessary.
Ansible also has a feature where you can store the password in an encrypted file.
Yeah.
So you can have the password for the machines in encrypted file, and when you run Ansible, it asks you for the password, not for the machine, but for the your password file, which Ansible man.
And you can even deploy it without root and make sudo in the background. So, yeah, there are a lot of possibilities.
I'm just asking about your way, yes.
Yeah, our way is that we distribute the key here, and when the key is available, and from this system, all this stuff is on one system. The Ansible stuff is on one system, just one, and because it's not a client server or whatever, it's very easy to deploy because we just install the OS, and then from a central place we push everything. Even in Amazon, we pushed it from here. So it's really on a central place. And we can have a large spectrum of possibilities.
The application, do you install it on every node? Or
Yes and no, depending on which cluster. For the moment, on Maya, we install it on every node because it's historically like that. And now that we are merging, we will install it on one node and deploy it with NFS. Yes. But for the moment, we have two things. On BC2, it's like that. And on Maya, for historical reason, because at this time, where we reinstalled, when we reinstalled the whole stuff, it's too late, we didn't have all these possibilities here. We didn't have a link to go directly to the storage and all this stuff. And then we just used what we had, and it's why it takes longer to reinstall the whole node at the end, because at the end we had to push the software stack. But this step will disappear in a few weeks completely, and here it's disappeared because this connection was already there.
I will go on the
Command on Ansible used for two purposes. One is installation of machines, and the one is updating of configurations.
And it's also deploying software. You can automate a lot of stuff.
So the reason why to have a slim or minimal installation image is that the configuration will have to change in one place in Ansible. And for the existing install machines, we push the update. And for the new ones installing, they automatically get new.
we can keep the configurations in Git. So you can do a branch in your Git repository of Ansible configuration, like this is the setup for the work cluster for day whatever, and you can always roll back there. You just install the resource and run the playbook in that day. We keep history of the cluster status somehow instead of
there is another thing which is really interesting. If you have a group of nodes and you have a software to deploy, you can say, I deploy it first on one node to see if it's working, trying, and when it's okay, you can deploy all over. So if you have a group, a bunch of 100 nodes, you say, okay, I use these 5, I deploy the new stuff on these 5 and only on these 5, and try the whole stuff, and when it's okay, then you deploy on the other one. So it's possible to upgrade in a different way. I will give now the hand to Pablo. He will give you a short overview of Ansible. Yeah?
How long did this take?
What?
How long did this take
For what?
for the merging of the system management, for the setting up of this?
I don't know what you mean, how long. The whole stuff, or it was over a month, because we make a lot of other stuff at the same time. But this part here is quite fast, quite easy to install. This was, a few weeks for the whole stuff. It's really very an easy tool to deploy and to use, because the configuration is really easy to understand and to read, and to write also. You don't have to learn a special language to make your playbook. It's a few configuration steps, and it's really very, very readable. So it's very easy to understand what's going on. And if you write a script or you write a playbook and your colleague comes later, he can just read it. I can show you some example later. It's really, when you go to Ansible, you have a lot of examples where they show you what they are doing.
In the interest of time, shall we move on?
Yeah. Yeah, so.
Okay. Okay. Good. Hi. Can you plug?
So Pablo will now really go into the details of the topics.
Okay. Wait a second, I'm not used to this. This place. I don't know, I'm going to the scroll. Mirror. Okay. Okay, I will show how we handle the scientific software stack, the typical modules installation we have in both clusters. First, the tools we are using to deploy all the scientific software is Lmod, which is a re-implementation of the classical modules. Basically, it's mostly compatible, or I will say 99% or 100%. I will go now in details why we switch from classical modules to Lmod. Then we use EasyBuild to do all the compilation itself and automatic generation of the module files. And then we use Automounter or Autofs for doing some tricks. I will go in details on this now. Probably many of you will ask why Lmod if modules work for so many years. So here I have put some of the nice features that Lmod has and the classical environment modules don't have. Like, well, first, it's compatible with what you have. So if you deploy Lmod and you point it to your current module files, it will work out of the box. The command line interface is compatible, so your users won't notice the difference, or their scripts will work the same. It has a cache, which is really useful because when you have many modules, we have around 300. So in the classical modules, you have to read 300 files each time you do ML/AB. In Lmod, you read only one file with the cache. You have collections, so you can say, for example, for pipeline 1, I need module this, module this, module this, module this. And then you save this as a collection. So the user can say, okay, module load, module collection load, or something like that, my pipeline. And all these modules gets loaded. You also have support for hierarchical module tree, which is something we don't use, but some scientific, some computing centers find it useful. It's basically, you log in on the machine, and you only get the compilers list when you do module AB. You load a compiler, and then on module AB, you get the list of software which has been linked with that compiler. And then, for example, the MPI. And when you load MPI, then module AB will show all the applications loaded with that MPI version. So people cannot do wrong stuff, because if they manage to load that module, it's because they have done the right stuff. Well, you can look at the details. We don't use it, but some people find it useful. Also, you have module properties, which means you can say, okay, this module has the property of being GPU, and this module has the property of being Intel 5. So when you do module AB, this module with the properties will get an star, and here you get even colors on module AB, which is a big change. And so, for example, all the modules with the GPU property can have a green star, and all the modules with Xeon Phi property can have a blue star. So you get an overview of which different things have your applications in a quick overview. You have also the ML wrapper, which seems a stupid thing, but it's really useful. For example, if you do only ML, it translates to module list. If you do ML and a module name, it translates to module load. If you do ML plus whatever minus whatever, it translates to remove this module, load this module. It seems stupid, but I'm used to that, and now when I need to use the classical environment modules, it's a pain, because it's much more faster to work with modules, only because it's this small detail. Also, you get more informative messages to users. So, for example, when it does an auto swap of modules, it will print on the screen, hey, I have switched this, be aware. Supports also more intuitive command line interface. You can, I don't know if you are aware, but environment modules by default output to a standard error. In Lmod, by default, it will also output to a standard error to keep compatibility with classic modules, but you can enable output to a standard output. Oops, sorry. If you want. Come on. You can also enable to a standard output. You have also case insensitive available. So the default modules is case sensitive. So if you put a capital letter in the module, many people won't find that. Also, it has provided modules usage tracking to syslog and MySQL. I think this is a really nice feature, which was released 2 days ago. We haven't tested yet, but we are going to get that in production for sure, to really be able to monitor what is the usage of the modules in our system, and also have some other some other advantages like push-em, families. For example, families is really nice. You can say that all your compilers are in the compiler family. So, and then Lmod will take care that the user can never load two modules from the same family. So if you have all the compilers in the family, the user won't be able to load 2 compilers at the same time. So you avoid users doing weird stuff. Also, the sticky modules, you can define a module which will be loaded by default for everyone. and can be only removed if you do module remove ---- force. It's, well, it has really nice features which are not in the classical modules. But really, the main reasons why we choose Lmod, because all these features are really nice, but for me, in my opinion, is Lmod is being actively developed. And not only that, the Lmod maintainer listens to you, listens for your feature requests and bug fixes. For example, the module AB case insensitive is something I asked him. I told him, hey Robert, I would like to have this. 2 days later, I got the patch. And he's, hey Pablo, test. So he really is really active, and when you report a problem, he helps you to fix it. And for me, this makes the difference. And also, there is quite active collaboration between Lmod and EasyBuild teams. And I think this is useful for us because it's both tools we use. And now the second tool we use, EasyBuild. Well, EasyBuild is a framework to automatize the build, installation of software, and also the generation of all the module files. As you can read here, EasyBuild fully automates builds and module file generation. So you run a command line, it will download source files, it will compile as you define, it will apply the patches you have set, will install, will do the sanity checking that all the files are in place, and will generate the module file. This, for me, is a killer feature. Easily, you reproduce your builds. You do your easy config once, done. Each time you need to reinstall this, you have it. Because, as an example, we have around 300 install modules, and I can reinstall our 300 install modules to the new cluster in one command line. Okay, it will take 1 or 2 days compiling, but human interaction is one command line, and I forget. And it will install exactly the same. Okay, probably if there is a new OS, something will happen, you know, but you can do it and probably fix some issues, but imagine reinstalling 300 applications by hand. I don't want to do it. Also, you can keep the software build recipes and specifications simple and human readable. Once you have learned how the system works, anyone in the team can read how it's designed, how the recipe is written, and can see how the software was built. This is also something that I think is really, really nice. Enables sharing of the recipes, because EasyBuild by default now includes support for 500 applications. And you can send your recipes. And anyone can send recipes, or even if you are in collaboration with our computing center, you can say, okay, this is the easy configs we are going to have installed in our system. And you share this, and each one can install these same recipes in their system. Each one can decide they want in a different install path, or they can adapt to their local needs, but they can share the same software, just sharing the recipes. This is, for me, it's really nice, because this is something that in all the HPC facilities, people is redoing. It's redoing the wheel once and again, and every time each one has their own build scripts. And with this kind of tools, really, you can do it once and forget, or at least have a start. Also, as I said, it has sanity checks. When the installation is complete, we'll verify everything is in place. Also, we'll do automatic dependence resolution. We'll retain the logs. So basically, if you do configure make install, you will get something on the standard output. All this output is saved to the log file. So when you install an application with EasyBuild, you will get the log file of everything what you would have seen in the standard output if you hadn't done it manually. So if some user comes and, hey, is the support for libpng enabled in this software? You go there, you check the log, and you see the output of configure. Oh, yeah, it found libpng, or it didn't find libpng, or whatever. You can always check how the installation complete. And this is done for you automatically. It has Git integration, so you can trace any change in the installed recipes. I will show you a few screenshots now. And then you can use it to automatize any install procedure. You can use autoconf, make, cmake, Python modules, per packages, custom install scripts, whatever. But anyway, most of the most used methods are already supported. So for example, we have 300 modules and we have only need to write 10 custom EasyBlocks. In EasyBlock is where you implement an installation method. For example, there is an EasyBlock for make, and there is an EasyBlock for cmake, and there is an EasyBlock for configure make. We only needed 10 custom blocks. Most of them, classical configure, make, cmake, blah, blah, all this is supported. Okay, oh, it's not seen nice. Shit. Okay, this is an example of the Git integration we have. This is our Git repository where we store all our easy configs. And you can see here, maybe, I hope, that 5 of June, I installed application XMEP 3.1 using toolchain this. A toolchain is just a group of compiler and libraries. Using EasyBuild 2.1 in the machine lee28.cluster.bc2.ch. And this is pushed automatically to Git. When I complete the installation, I save all this information automatically. So if I go to if this is just the commit history, so each of these commits shows you which application was installed, where, and how. And then if you go on the details on the commit itself, I'm sorry you cannot read, in my screen I can. But here you get the machine name where it was compiled, the kernel version of the machine, the number of cores you use for compilation. These are all the specific EasyBuild config lines you use for installation. The build, how long took the build, how much space it took the installation. All the details about your installed software are automatically pushed there to Git. And if I reinstall this application, well, it's Git. So you get history of what is going on. And okay, before going into Automounter, I would like to say also that EasyBuild, what I will remark also is a software which, because I have seen other build systems which are really site hard-coded. So we have a build system, we publish it, but it's really hard-coded to our requirements. But EasyBuild has really been designed so it can fit any custom site customization. For example, they provide a default modules name schema, but if you need a different one, you can change it. They provide some tool chains, but if you need a different one, you can. They provide different dependencies for the packages, but if you want to rely on system packages, you can. And also, it's a quite open community. I mean, if you go with nice ideas, probably they will hear you. I have asked for a few features, and they have added because they think they were nice. I have also sent them few patches, and they merged it to the master branch because they like it. So, I mean, it's not something you need to fit to how they work. You can adapt to your workflow, and even you can add features you need for your workflow. For me, this is also really important because it's impossible everyone works the same. So it's important it's a flexible tool which can fit all the requirements. Okay, and the last step, once we have installed all the applications, we use Automounter to do some magic so the user don't notice which software stack they are using. What we do is we compile all the application for all of our CPU types, enabling the compiler optimizations, like march native or yeah, I think it's a march native. And then, or for Intel, whatever is it. Then, so that means we keep few identical software stack, one by CPU type we have. We have a software stack for EV Bridge, software stack for Sunday Bridge, software stack for Bulldozer, and because as EasyBuild allows us to reinstall the same application as many times as we want, doing this without EasyBuild will be a nightmare. But once you have it in EasyBuild, okay, you run it twice or you run it 3 times. And then with Automounter, what we do is we keep the software path the same in every machine. So for the user, the software path is always sciCore soft apps everywhere in any machine. This will never change. But what we do is, depending on the CPU type on the machine, Automounter points to the right software stack for this CPU type. The software stack which is optimized for this CPU type. So this means that depending on the machine where the job runs, the software stack optimized for this CPU type will be used. And the user, this will be transparent for the user. They won't notice anything. They just do the classical module load whatever, and then if they are using OpenBlast, they will be using the version of OpenBlast which is optimized for Ivy Bridge or for whatever.
But
Yeah.
you change the workload in a heterogeneous environment. Will you have the same numerical results in every architecture?
This is something I have thought about, and I don't have a reply. To be honest, I have thought that I don't know if this can be. It's also true that usually one user they used to go to one type of machines. For example, on BC2 now everything is Bulldozer. So.
Because it's interesting, in Java 8 they have introduced the mark string libraries, which will give you exactly the same result in every architecture, but I think it's not easy to achieve.
Yeah, I have think about that. Yeah, probably it's, to be honest, also, this can be a bigger issue for the Maya side, because it's where we still haven't implemented this, but we have to. This can be an issue because on the Maya side there are physics, chemistry, and this kind of users. In BC2 side we have bioinformatics, and they won't notice that. I don't think so. They are not heavily using mathematical libraries, and they are using mostly Python, Perl. By the way, they are who will feel this optimization less, because you will feel this mostly for a mathematical library. Yeah, but it's a really good question. Yeah. And okay, and next step we have in our roadmap for this is we are thinking about submitting the jobs to the cluster to do the builds. So we submit an EasyBuild job to the cluster, compilation, write to this, git push with the results, done. We are thinking about using in the next EasyBuild release, there will be integration with this. This is a framework for queue integration. And the guy who is who is working on this feature is Ricardo Murri, who is working at Zurich, and he will talk about this topic this afternoon. Also, we are thinking about the possibility, or exploring it, of generating RPMs with EasyBuild, because the next EasyBuild release will also include FPM integration to generate RPM or the packages. We are also thinking about the possibility to use Docker. There are some applications which maybe it's worth to do a Docker container, especially for these crazy bioinformatics applications which require 100 to 2,000 different libraries from 2 different sources. One is, well, installing it will break your system, basically. So maybe using Docker for these exceptions could be a good idea. These are just things we are thinking about. We have nothing working. And okay, and the EasyBuild release manager knew I was doing this talk, and he asked me to announce that before the next supercomputing, we will have a EasyBuild hackathon with the EasyBuild developers and also the Lmod developers in Texas Advanced Computing Center in Austin. So if you are interested in EasyBuild, you can, and you are attending supercomputing, by the end of the year you can attend. And that's all. If you have any question.